Good afternoon, one and all present here. I am going to discuss about classification of signals and system. So these are the outline of my presentation. Introduction to signals and system, classification of signals, elementary of signals, introduction to systems, types of systems. So first we are going to discuss about what is signal. So signal is defined, it is a function of one or more independent variables. Generally the signal is used to convey the information from one place to another place. So generally we can define the signal is physical quantity that varies with one or more independent variable. So some of the examples of signals are ECE signal which is represented by electrical activity of the heart, speech signal which represent the speech, that is sound which produced by human. So signal basics, generally the signal is classified into two types, discrete time signal and continuous time signal. So this is the discrete time signal. So this is discrete time signal. So it can be represented x of t. This is continuous time. So this is continuous time signal. It can be represented x of t. So this is discrete time signal. It can be represented x of n. So we can determine the amplitude of this signal at anywhere of time. So in this discrete time signal, we can determine the amplitude of the signal at only particular interval. Okay. So here the difference is, here this parenthesis is used for represent the continuous time signal. This square bracket is used to represent the discrete time signal. So analog signal. So one of the best example of analog signal is human voice. So generally our human ear recognize sound up to 20 kHz. In AM radio we have to use 535 kHz to 1605 kHz. In FM radio works in the frequency range of 88 MHz to 108 MHz. So the digital signal, generally the digital signal can be represented by square waves. It can be represented either ones and zeros. So single binary digit is called as a bit, group of bit is called as a stream, bit stream. So this is analog and digital signal. So what is the advantages of analog signal? It is best suited for audio and video signal. It consumes less bandwidth. It is generally analog signal is available in it is available in worldwide. So best example is television and radio signal. It is less susceptible to noise. So this digital signal, it is best suited for computer data. It can be easily compressed. It can be encrypted. It is a less expensive. It also provides a better quality for images and videos. So what is communication system? Communication system. Communication is generally nothing but exchange of information from one place to another place. So this is the general block diagram of communication system. So generally the communication system consists of transmitter, channel and receiver. So in receiver we get the transmitted signal plus noise signal. The receiver is used to process the received signal and remove the noise. We can transmit the destination. Elementary of signals. So sinusoidal signal and exponential signal are important in signals and system analysis because it comes naturally from the solution of the differential equation. So generally we can sinusoidal signal can be expressed in two forms. One is frequency form, another one is a radian form. In frequency form it can be represented as sin 2 pi f naught of t. In radian form it can be represented as sin omega naught t. In exponential signal there is a two form. One is real exponential, it can be represented e power omega naught t. In complex exponential it can be represented e power j omega naught t. So next we have to discuss some of the basic functions. Unit step function. So generally whenever the amplitude of the signal is 1, it is called as a unit step function. It can be represented as a u of t E of t is equal to 1 when t greater than 0. When t less than 0, it is a 0. So this is the general graph. Commonly used graph is that one is actually it likes staircase step, that's why it is called as a unit step function. So signum function, so it is closely related to the unit step function. So signum function, it consists of signum of t is equal to 1 when t greater than 0 minus 1 when t less than 0. It is used in sampling process. So unit ramp function, it is denoted R of t, that is here the amplitude of the signal is increased linearly with respect to time. It is denoted R of t is equal to t when t greater than 0. R of t is equal to 0 when t less than or equal to 0. So it is the integral function of the unit step function. Already we know that E of t is equal to 1. So when we integrating this one, that is 1 into dt. So we get the t. T is nothing but ramp signal. So rectangular pulse or gated function. So rectangular pulse and gated function is denoted as del of t. Del of t is equal to 1 by a when t less than a by 2, 0 when t greater than a by 2. So representation of impulse function. So the area under the impulse is 1, it is called as a unit impulse function. So it can be represented del of t. So generally the unit impulse function del of t is equal to infinity when t is equal to 0. When it is 1, when t is equal to 0, this is called as a unit impulse function. So some of the properties of impulse function: sampling property, scaling property, replication properties. So unit rectangular function, so it is the combination of two shifted unit step signal. So it can be represented as rectangular of t is equal to E of t plus a minus E of t minus a. So mainly it is used in processing the signal. So unit triangular function, here the triangular pulse whose height and area are both 1 but width is not equal to 1. So mainly it is used to this signal, this type of signal is used for convolution purpose. So sinc function, so this is one of the important mathematical tool used in the signals and system. It is used to reconstruct the signal, sinc function. So here the difference between the normal sine signal and sinc signal, so only this part only high amplitude, other side loops are only small amplitude, but in sine signal all the signals are having the same amplitude. So now we are going to discuss about some of the basic operation of signals. So different operations are required for different purposes of arbitrary signal. So some basic operations are time shifting, time scaling, time inversion or time folding. So the first one is time shifting. We have to shift the time signal either left or right. Here, so first we have to shift the right side. So it is called as a signal delayed. So that is here, this is the original signal, this signal is shifted to the right. So we can write x of t minus t naught. So time shifting, so another one example is here, the original signal is shifted to the left. So it can be represented as x of t plus t naught. So here the signal is advanced, here the signal is delayed. So this is the original signal. So here this is the original signal, we get only the output here. So that is the signal is delayed here. Here the signal is advanced. So time scaling, so here we have to perform some scaling operation in the time unit. Okay. So normally it is denoted x of t. So x a of t, that is here the scaling factor is used in the timing, used in the time period. So when A is greater than 1, it compresses the signal. If A is less than 1, it expands the signal. For example, if x of 2t, it compresses the signal. So here the speed is increases. X of t by 2, that is here expand the signal, the speed is increases. Actually multiplication operation is perform the compression, and expansion, the division operation is perform the expansion operation. So this is the one example. So this is a y of t, y of 3t. So here the time is divided, so the time is compressing, here the time is expanding. So here y of t is equal to y of 3t. Here the time is compressed by 3 unit, here the time is expanded by 3 unit. So time reversal. Time reversal is nothing but just time folding, that is a mirror image. So y of t is equal to x of minus t. So this is the one of the example. So whatever the signal is available here positive side, that will be replicated in the negative side. Whatever the signal is available in the positive side, that will be comes into the negative side. So classification of signals. So we can classify the signal is 4 types: deterministic and non-deterministic signal, periodic and aperiodic signal, even and odd signal, energy and power signals. So deterministic signal, we can predict or determine the amplitude of this certain behavior of the signal is called as a deterministic signal. We can write the some mathematical expression for that signal, that is called as a deterministic signal. We cannot write the certain mathematical equation, that signal is called as a noise signal. So one of the best example of the non-deterministic signal is non-deterministic or random signal. The best example is thermal noise. So periodic signal. Periodic signal is nothing but the signal is repeat after certain interval of time. So this is a one period, so again it will repeat. So this signal is called as a periodic signal. So some of the conditions are available for periodic condition, that is x of t is equal to x of t plus t naught. So for example, x of t is equal to a cos omega naught t, omega t is nothing but periodic signal. So if the condition is not satisfied, the signal is called as a aperiodic or non-periodic signal. So here the signal does not repeat after certain intervals. So this is the condition for discrete time signal. So we can sum the two periodic signal, always not a periodic, it may be periodic or aperiodic. For example, we have to consider the two signal here. One is x cos t, another one is a sin root 2t. So generally square root value, then pi, it is a irrational number, not a rational number, it is a aperiodic signal. So the second term is aperiodic. So we have to sum these. This is periodic signal, this is non-periodic signal. We can sum the two signal, we get the aperiodic signal. So even and odd signal. So even signal is symmetric about the vertical axis, is called as a even signal. So this is the even signal. So symmetric about the vertical axis, that is nothing but symmetric, the even signal. So this is anti-symmetric about the vertical axis, that is called as a odd signal. So we can product or odd or difference or derivative or integral of the even signal, odd signals. So generally product of two even and odd signal. Here product of two even signal. We can product the two even signal, we get the even signal. So this is the even signal. Here product of even signal and odd signal, we get the odd signal. So this is another one example. This is even, this is odd signal. Product of these two signal, we get the odd signal. So product of two odd signal, we get the even signal. So this is like minus product of plus into the plus into plus plus, minus into minus plus, so like that only. Various combination of even and odd function. So actually we have to sum the two even signal, we get the even signal. We have to difference the two even signal, we get even signal. Product of two even signal, we get even signal. So adhe mari division we get the division of two even signal, we get even signal. But even and odd,